Welcome to our series of solving HC Verma one question at a time. Today we have a question. Suppose all the surfaces in the previous problem are rough, the direction of friction on B due to A is. So the previous question was that only the surface between A and B are rough, and contact are rough, and the surface and no other surface is rough. So in that question, the answer was there will be no equilibrium. So in this question, there will be equilibrium because there is this force, and due to which there will be normal force here, normal force here. There will be friction here. There will be friction here. Supposing that F is obviously enough amount of force to keep this in equilibrium. At the equilibrium, we will know that the only force, like this is an equilibrium, right? Suppose that B is at a height of 5 meters from ground. At equilibrium, it will remain at 5 meters, so it is not going down. The force downward will be, suppose the mass of B is mg, right? The force downward is mg. The force in horizontal doesn't matter for the height, only the force in vertical matter. So if this is in like equilibrium, the force of friction on B due to A will obviously be upwards. Why? Because that is the only thing that makes sense, right? B is in an equilibrium, it is not changing its height. There is a force acting downward, which is gravity, so there will be only one another force in the vertical, that is friction, so that will be in the upward direction, which would balance the force out. So we can also say that if the mass of B is m, the upward force will also be equal to mg. The frictional force is in upwards direction. Here is your answer. Thank you for your time.